You to record. You can start recording. Okay, so the thing is today we will have a short class because we don't have much syllabus left for chapter 1. So in chapter 1 we will start um, actually in the last class I think we have completed the Bayes theorem, isn't it?
Yes, sir.
Have you completed Bayes theorem?
Yes, sir.
Okay. So this solution also we have solved. I mean the Bayes solution. I mean Bayes theorem. We have this P of B condition A will be equal to P of A condition B into PB by PA. That was there, and we talked about this example 1.20. And from the previous example 1.19, we had some values that we already have found, that is PA, and then PB3 was found, and then um, again we can find out the PA condition B3 that actually we knew from the previous solution, previous example. Now in this example they wanted to find out this P B3 condition A, and from the Bayes theorem we can directly find out this P B3 condition A, because the all these three values we know from the previous example, and then we can put it out, and then we can easily find out the probability of B3 condition A. Okay, all right. So the thing is, this Bayes theorem is that one. Now today we will start with this independence. Okay, with the independence we will start, and then you can see that this independence, how actually the independence is working. All right. And the thing is, when we are talking about independence, then we have to have some criteria. For two individual events are independent, what are the criteria? There are two criteria. Okay, number one is probability of A must be equal to probability of, probability of AB must be equal to probability of A into probability of B. Say for example, we are having these two events A and then B. Okay, and event A and event B, these two events will be independent only if, or if and only if, probability of A multiplied by probability of B, that will be equal to probability of AB. Do you understand? Remember one thing, this probability of A and probability of B doesn't need to and that doesn't mean actually that there has to be disjoint or not disjoint. Say for example, if they are like this one, this is A and this is B, probability of AB is what? We know that probability of AB is actually probability of A intersection B. Okay, say for example, they are overlapping, so there must be a value PAB. They are overlapping doesn't mean that they are independent. They are overlapping, that means there will be some common area, and that is PAB, but doesn't mean that they will be independent. There has to be this probability of A and probability of B, if I multiply with each other, and that result will be equal to this combined area. So this is one very important criteria, that two event will be independent if their multiplication of probabilities will be individual probability multiplication. Is it clear? Is it clear?
Yes, sir.
Okay.
Sir, you
So
mean?
the thing is, this is, yes.
Can you repeat again?
The thing is, look at one thing. I am having a universal set. Within the universal set, I am having a event A and event also B. The thing is, prob A and B, they will be independent only when this probability of AB will be equal to probability of A multiplied by probability of B. This is the condition. This is the condition for two independent events. A is one event, B is one event. A will be independent of B. It means their PAB, or you can say A intersection B, that will be equal to probability of A multiplied by probability of B. Very simple. Okay, say for example, probability of A equal to say zero point 0.3 and probability of B equal to 0.4. So their multiplication equal to what? Their multiplication equal to 0.12, and probability of AB has to be also 0.12. If they are equal like this, then we can say that A and B are independent. Is it clear? Now,
Yes, sir.
okay. So the thing is, this is one criteria for two independent events. Another one is what? When events A and B have non-zero probabilities, the following formulas are equivalent to the definition of the independent events. This is the same as this one or this one. What is this? They are telling when A and B are independent, it means what? It means A doesn't have any effect or effect on B, and also B doesn't have any effect on A. So if they are independent, then we can say that this one is equal to directly probability of A. That means whether B is happening or not, that is not influencing the probability of A. So probability of A is same as the prior probability. So the conditional probability will be equal to the prior probability, because A is not dependent on A, I mean on B. So whatever B is, B has no effect on A. Similarly, the other thing is the same. Probability of BA will be equal to probability of B. Is it clear?
Yes, sir.
Yes, sir.
Okay. So these two criteria we have to think about. If I give you what are the criteria for independence, then you have to put these two criterias in your answer sheet. Number one criteria is probability of AB equal to probability of A multiplied by probability of B. Number second criteria is probability of A condition B will be equal to probability of A. And the same time, probability of B condition A will be equal to probability of B. All right. So this is for two events. Two events. But if it is more than two events, say for example, three events like A1, B1, or A1, A2, A3, or we can say ABC. Three events like ABC are there. So if ABC, what is the criteria for A, B, and C to be independent? Condition for three events to be independent. Okay, there are 4 conditions. Number 1, A and B are independent. So if A and B has to be independent, they have to follow these 2 criteria, isn't it? So for 3 events to be independent, number 1 criteria is A and B are to be independent. And for A and B are to be independent, A and B has to follow these two criteria. Number 2 is B and C are independent. Number 3 is C and A are independent. And number 4, what is number 4? Number 4 is probability of A intersection B intersection C, that has to be equal to probability of A multiplied by probability of B multiplied by probability of C. So these are 4 criteria that has to be fulfilled for A, B, and C to be independent. Is it clear?
Yes, sir.
Okay, I'm telling it again. A, B, and C, for them to be independent, we have to follow, or we have to meet the condition. We have to meet 4 conditions. Number 1, A and B has to be independent. Number 2, B and C has to be independent. Then number 3, C and A has to be independent, and their intersection, A, B, C, their intersection has to be equal to probability of A into probability of B into probability of C. If ABC follows these 4 criteria, then we can say ABC are independent. And remember one thing, for every one, for number 1, number 2, number 3, if we have to maintain this, we have to follow these 2 criteria for each of them. All right? Is there any question regarding independence? 2 events or 3 events? Is there
Sir,
any question?
if there is no intersection between 2 events, won't the probability be 0?
If yeah, if there is no intersection, say for example like this, A, B, and C, there is no common part between A, B, and C, so that is equal to 0. So probability of A into probability of B into probability of C, if they are uh, all some value, and if the multiplication is not equal to 0, that means they are not independent. Actually, the condition is A, B, C. I mean, probability of A, probability of B, probability of C, they has to be non-zero. So if they are non-zero, actually we can say if they are no common part, actually they cannot be independent, isn't it? So there has to be some common part to be independent actually.
So they'll have common parts, but yet they'll be independent.
Yes, yet they will be independent, right?
Okay, sir. Thank you.
Okay. Is there any other question? Okay. So this is the independence thing. Now let's go to the next slide. Okay, let's solve this problem. At first, you read the example 1.25. Okay, so what actually they are telling, suppose traffic engineers have coordinated the timing of two traffic lights to encourage a run of green lights. Okay, what are they telling? Suppose traffic engineers have coordinated the timing of two traffic lights to encourage a run of green lights. All right. In particular, the timing was designed so that with probability zero point 0.8, a driver will find the second light to have the same color as the first. Assuming the first light is equally likely to be red or green, what is the probability of PG2 that the second light is green? Then they're telling also what is probability of W. What is W? The probability that you wait for at least one light. So W means wait. Okay. Lastly, what is probability of G1 condition R2? The conditional probability of green first light given a red second light. Okay. So there are several questions. Several questions. At first, we need to find out the tree diagram. Otherwise, we will not be able to solve. Okay. So let's draw the tree diagram. What are they telling? They're telling there are two light. This is one light. This is one light, say for example, and this is another light. Okay. Actually, what they are telling that there are two traffic lights to encourage a run of green lights. Run of green light means what? I mean, when the first one is green, second one will be also encouraged to be green, so that the people who are getting green hair directly can get green hair and can go directly. Okay. So the timing was designed so that the probability of with the probability 0.8, a driver will find the second light to have the same color as the first, assuming the first color or first light is equally likely to be red or green. So the first light actually is equally likely. So the first light, when it is getting, it can be either red or it can be green. Okay, or it can be green. All right. Now this, what is the probability? Probability for red. Probability for green is, I will say that this is the green first light. So I will say this is G1. This probability of green first is equal to how much?
0.5.
0.5. Very good. Because this is equally likely. Okay. What about the probability of red light?
Half.
This is also half. Probability of R1, I will say, that is also equal to half or equal to 0.5. Okay. Now the thing is, if the first light is a red light, okay, if the first light is a red light, then it can be again in the second slot, it can be again what? Again it can be green, I mean red, or it can be green. Isn't it? It can be red, it can be green.
Yes, sir.
Okay. In the second slot, similar way, it can be green or it can be red. And we can say that this red is a second red, or we can say probability of R2 equal to what? I don't know. What is probability of R2.
0.8.
Right. Why? Look at this one. It is so designed so that with probability 0.8, the driver will find the second light to have the same color as the first. So if the first color is a red color, then the second red color probability is 0.8, because the same color probability is 0.8. But what
Sir.
about, yes,
So shouldn't it be red plus green is equals to 0.8?
no, not plus.
Wording in the question is really confusing.
No. Remember one thing. They have told it in the next line that assuming that the first light is equally likely to be red or green. That means first one is 0.5. But the timing was so designed so that the probability 0.8, a driver will find the second light to have the color as the first light. Probability of second light. You have to find the second light. Probability
The
0.8.
second light can be same as that of the first for either red or green, right? So
No. Remember one thing. Second light probability is 0.8 when the color will be same as first one. You understand? Look at that. Again, was designed so that with probability 0.8, a driver will find the second light. So this probability is for second light probability to have the same color as the first. So the probability is for second light, and the color is, the second light color can be red or green. So which one is 0.8? Whose color is same as the first one? That is 0.8. So if that is 0.8, the green will be what?
0.2.
0.2. So this probability of green 2 is equal to 0.2. Similarly, this green will be what?
0.8.
0.8.
Right? This green will be 0.8.
Sir.
And that red will be what?
0.2.
That will be 0.2. Is it okay or not? Tell me.
Yes, sir.
Sir,
Yes.
how do you get the 0.2?
Remember one thing. When I'm talking about this point, what are the possible lights? Tell me.
Red and green?
Are there any other option possible?
No.
No. So if I find that green light probability is 0.8, then what is the red light probability? Because combinedly they are 1. So that red light probability will be 1 minus 0.8 equal to 0.2. This 0.8 is given in the question. Look at this. This is a bit confusing, but you have to find it. The timing was designed so that with probability 0.8, a driver will find the second light to have the same color as the first. It means if the first color is a red color, actually there is a problem. There is a problem. A problem means actually our color actually we should avoid this. This should be a green line. Then it will be clear. Is it clear now? First one is a green color. So the second one will also be green with probability 0.8 according to the question. And if it is 0.8, the other one has to be 0.2 because combinedly they are 1. Is it clear? Otherwise, I will tell it again. No problem.
You can say it again. It's a bit
Okay.
confusing.
Which part? Tell me which part. Why this red part is 0.2? This
Yes.
one.
Yes.
Have you understood why the green part is 0.8?
Yes, sir.
Then what is the problem of getting 0.2? Because this one in this point, when there are two possible options, one is red and the one is green, isn't it?
Yes.
So if the green one is 0.8, what will be the red one? 0.2, because only there are two options, either red or green. Combinedly they are 1.0. So if one is 0.8, the other will be 1 minus 0.8 equal to 0.2.
Oh, okay, okay, sir.
Okay. All right.
Yes.
All right. Let's now proceed. Okay. So let's do these things. Okay. All right. Now our work begins. Now what? Now the thing is, they are telling, assuming the first light is likely to be greater than green, what is the probability of G2? What does it mean by what is the probability of G2? G2 can happen in two ways, isn't it? Second one is a green in two ways. One is, first one is a red, then second one is a green. Another way is, first one is a green, then second one is a green. Do you agree?
Yes, sir.
Do you agree with me?
Yes, sir.
Okay.
Yes, sir.
So there are two paths. One is this one. Another one is this one. So in these two way, G2 can happen. So when I want to find probability of G2, then how to do that?
So
Then the
0.5
first
into
line
10
is what?
plus
First line
0.5
is probability of R1 multiplied by probability of G2. This is this line probability. Do you agree? Do you agree?
Yes, sir.
Because this G2 can happen. First one is red and then second one is a green. So this combined probability, to find out, we have to multiply what is the probability of red and what is the probability of green. Then actually we will find this whole line probability. So this is the probability of R1. First one is R1. Then into probability of this probability of what? G2.
G2R. Conditional.
G2. Isn't it? Do you agree? This
Yes,
is
sir.
one line probability. But G2 is not only the single line. We need another line, which is this one. And that line probability is what? Probability of G1 first and then probability of G2 second. Probability of G1 multiplied by probability of G2. Do you agree?
Yes, sir.
No, sir, or yes, sir?
Sir, in the first part, shouldn't it be probability of R1 into probability of G2 conditional R1?
You can say that. You can say actually this G2 is the same as probability of G2 condition R1.
So because they're independent.
They're independent, right? They're independent. They're independent. Because actually we can say that G2 R2 R1 means what? At first R1 happen and then G2. You can say that.
Okay, sir.
Actually, this not only this G2, actually we should not say G2, because you'll be confused then with G2 and this G2. We should say here G2 condition R1. That will be more appropriate. And that one should be G2 condition G1, isn't it?
Yes, sir.
G2 condition G1. That will be more appropriate. Do you agree?
Yes, sir.
Yes, sir.
All right. So what are the values? Let's multiply. Probability of R1 is 0.5. Then probability of G2 condition R1, that is 0.8, 0.8. And then plus probability of G1 is 0.5 again. And then probability of G2 condition R1, G1, it is 0.8. Okay. So no. We have done a mistake.
G2 condition R1 is
This one is not. This one is not 0.8, isn't it? This one is 0.2, and that will be what? 5 10, that is 0.1 plus 0.4.
Sir,
That will be 0.5. Yes.
0.5.
your voice is very low. I don't know.
Is it okay now? Is it okay now? Is it okay?
No, sir.
Not okay. Is it okay now?
It's perfect for us.
I think it is okay. I think it is okay. You increase your volume. Maybe your speaker volume is less. Maybe.
স্যার একটা কোশ্চেন ছিল স্যার।
Yes, please.
স্যার এখানে কোন দুটো কন্ডিশন ইন্ডিপেন্ডেন্ট, G1 R1 এরকম কিছু?
Independent, if you want to say, then actually this G2 condition R1, these are conditional probabilities. No one actually has told about this as independent. Why the independent question comes? Because it is given after the independence question. That's why you are talking about independence.
Yes sir, I thought like it is related to independence.
Actually, we haven't found so far independence because these are conditional probabilities actually.
Okay sir, sorry sir.
Okay, look at this one. So what actually we are talking about is 0.5 multiplied by 0.2, and then we are finding 0.5. So this probability of G2, that one is actually equal to 0.5. 0.5. Is it okay?
Yes, sir.
All right. Now let's go for the next problems. Okay. So we have understood all these things, and then let's solve it. The next one. So that one we have found what is the probability of G2 that the second light is green, and we have found out the result. Okay. Also, what is PW? The probability that you wait for at least one light. What does it mean? Tell me, what does it mean? Also, what is PW? The probability that you wait for at least one light. What does it mean? What does it mean? Wait. I mean, when do you wait?
Sir, wait when there is a
Red light.
Red
When there's a
light.
red light.
Red light, right? So when there is a red light, then actually you wait. So they are telling to find out what is the probability of W. What is that is the probability that you wait for at least one light. So in your path, you are seeing or you're watching two traffic lights, and if any one traffic light is red, then you wait, and they are trying to find out what is that probability of wait. So how many combinations are there? This is the first light, this is the second light. How many combinations can be possible? Red, green, then green, red, and then green. Is there any other possibilities? No. So there are 4 combinations: green, red, red, green, red. And they are telling when you want to wait at least one red. So this is, you have to wait. This one you have to wait. This one also you have to wait, but this one, no wait. If both the lights are green, you can directly go and you can find out. Okay, there are two ways you can do it. Number one, find this probability, that is probability of G1, and then probability of G1 R2, probability of G1 R2. This is the one weight. Another weight is what? Probability
R1,
of
G2.
say for example R2 G1. Another way is probability of R1 R2, isn't it?
Yes, sir.
So these three cases we have to wait. So if somehow we can find out their probability, then we can add them and we can find out the probability of W. How can we do that? What is the probability of G1 R2?
0.2.
G1 then R2. No, why 0.2?
Sir, from the tree
0.1.
diagram,
This one,
G1.
this one,
Yes, sir.
0.5 into 0.2, isn't it?
0.5 into 0.2.
Oh,
Look
okay,
at
sir,
this.
okay, sir.
This
Yes,
is
yes.
G1 R2 means what? G1 into R2. That means they are common part,
sir,
or we can say that they are multiplication. G1 into R2. So that will be what? 0.5 into 0.2, and that will be equal to what? 0.1. Do you agree?
Yes, sir.
Okay. Now I want to find out R2 G1. What is R2 G1? G1 into R2. G1 R2. No, this is the same. This is the
Shouldn't
same.
it be R1, G2?
It should be R1 G2, right? It should be R1 G2. It should be R1 G2. It should be R1 and G2. So it should be R1 and then G2. Okay. If it is R1 and G2, what is that?
In 0.1. 0.5
Again
into
0.1, because it is again 0.5 into 0.2, and that will be 0.1. Are you understanding? If
Yes,
not,
sir.
Yes, sir.
please tell me. Please tell me so that I will repeat again. Don't worry.
Sir,
Yes.
sir, is the question like when the two lights are green, then I can move, or else I will have to wait? Is it like that?
Yes. Yes.
Okay, sir. The language is actually very confusing, sir.
My language is confusing.
I mean the question, sir.
Yes, this is the language of the book. So you have to understand the book language. Otherwise, you will not be able to answer that one. Okay. So what is PW? I mean, they are actually twisting. They are twisting the language. What is PW? The probability that you wait for at least one light. So they are actually twisting. So this is the thing. Now, what is probability of R1, R2? What is
0.5 into 0.8.
0.5 into
R1, R2? So R1, R2, it is 0.5 into
0.8.
0.8, and that will be equal to 0.4. So if I want to find out probability of W, then we will do what?
we will add
Add
them.
Add
on.
all
these
these.
up.
Add these up. 0.1 plus 0.1 plus 0.4, and that will be equal to 0.6. And that is the result for the probability you have to wait. I told you that there are two ways. What is the other way?
Sir, we find out green and minus it from 1.
Right, very good. We will find green, G1, G2. Because if we find G1, G2, this is the probability that you can go. So if I can find out the probability of go, then I can find out the probability of wait, because probability of go plus probability of wait equal to 1. So what is the probability of G1, G2? Tell me.
It will
0.4.
be 0.4.
That is 0.5 into 0.2, sorry, 0.8, isn't it? and that will be 0.4. And if you subtract it from 1 minus this probability of G1 G2, and that will find 1 minus 0.4, and that will be 0.6, which is same as this one. Is it all right?
Yes, sir.
Is there anyone who didn't understand this one? There are two ways. I told you. You can either add this, either you can add this, and this, and then you can find out this 0.6. Otherwise, you will find out this 0.6 from here, and then all the same thing. This is the more easier way, isn't it? Easier way to do that. Is there any confusion regarding this?
Oh, sir.
If not, then let's solve the last one.
Sir, we have already solved the G1 R2, isn't it?
Have we?
Yes,
Yes,
sir,
sir.
because the first one is green and the second one is red. So we have already drawn the tree.
Yes.
So the probability should be 0.2, right?
Which one?
The red P of R2 in the green branch.
P of R2 in the green branch. P of R2 in the green branch. 0.2. Yes. Why are you thinking about this one?
Sir, because G1 already happened and then the condition of R2.
This one is not the. This one is not the same as probability of R2 condition G1 or something like that. I mean, why are you thinking about this one?
Sir,
Sir,
isn't
I
it
have
like
solved
because
it
G1 already
using Bayes
happened?
theorem also. This thing.
Are you trying to find out this one?
Yes, sir.
This is what? This is probability of G1 condition R2. Is it given?
Sir, we found it from the tree.
No.
Sir, I also solved using the Bayes theorem, and they're the same.
No. Probability of G1 condition R2 is what? This is probability of R2 condition G1.
Sir,
Are
got
these
it.
are these same?
No, sir, not the
No, sir,
same.
no, sir.
Then why are you thinking about this one?
Oh, sir, then maybe I have mistaken, sir.
Yes, because this one is, we need to find out the first event probability condition that the second event has happened. We haven't done it yet. For this
Yes,
one,
sir.
you have to use the Bayes theorem,
Yes, sir.
isn't it?
Yes, sir.
Because the probability of G1 condition R2 is given, but not probability of R2 condition G1 is given. So what is the probability of G1 condition R2? That one is probability of G1 R2 divided by probability of R2. Isn't it?
Yes, sir.
This is the case. Now, G1, probability of G1 and probability of R2 is actually what? G1 is 0.5 and probability of R2 is what? 0.2. So if I multiply, then that one actually will be 0.4. Can we say that?
Yes, sir.
Probability of G1.
G1
R2.
R2. Sir, isn't it
G1.
0.1?
Isn't the formula
Yes,
wrong?
yes, it is 0.1. It is 0.1. That's what I'm talking about. It is not 0.4. It is 0.1. 0.1. Isn't it? Now, probability of R2. Have we found probability of R2?
Sir,
Yet?
we have already found probability of G2 equals to 0.5.
Right.
So R2 should be 0.5 as well.
Right. Probability of G2 is equal to 0.5 that we have already found out. So if we can actually find out probability of R2 as well, and that will be 1 minus 0.5, and that will be 0.5. Okay. Now, if I put it here, then actually we think we can find it. What is that? That one is 0.5. So we can say that that will be probability of G1 R2. Let's we don't have space. Probability of G1 R2, that one will be what equal to 0.1 divided by 0.5 equal to what?
0.2.
0.2.
Yes, sir.
Okay. 0.2. Okay. So we are having this 0.2. That is the probability of G1 condition R2. All right.
Yes, sir.
Okay. So this is G1 condition R2. There is 1 by 0.1 divided by 0.5. Okay. Okay. All right. So is there any question left? Is there any other question? So this is the results for so far we have seen for this example, and then let's move in the next slide. Let's see what happens about the results. Look at the results. Okay, look at the results. The results, already we have done this way. Probability of G2 equal to 0.5, this white equal to like this, and the white equal to 0.6, and then probability of G1 R2 will be like for probability of R2 actually we have found out 0.5 because probability of G2 is 0.5 already, and we can find it out from here. And then this G1 R2 is 0.1, we have already found out, and this probability of G1 condition R2 will be 0.2. So is there any other any question that you can ask about this problem? I told you that there will be a short class. So actually, and that is the end of this chapter. Okay. So regarding this chapter, if you have any question, you can ask regarding this chapter.
So where should we practice the maths from for this chapter?
From the exercise, the book that I have already told you, that Yates and Goodman book, I have already shared it
Right.
in the Google Classroom. So from that book, examples you can solve it, or the exercise, or you can follow other books as well, because I have already given you the course outline, and in the course outline you can find some reference books. So from those reference book as well, you can solve some problems. All right. Or also you can in the net also you can find out probability problems. So you can solve from anywhere actually.
Okay.
All
Okay,
right.
So will
sir.
you be providing us with this slide specifically?
Definitely.
Thank you.
Definitely. Maybe to
So, sir,
yes.
when are you going to provide the slide?
Maybe today. Today I will share these slides in the Google Classroom. So in the Google Classroom, if you visit, then you will see that I have already shared. Although not already actually, I will share it today. So today,
Okay.
at the end of today, you will find the files.
Sir, is there
Uh,
any specific solution manual that we can follow for this book?
Solution manual, actually I have the solution manual of the book. I don't want to give it to you, but I think if you try, you can find the solution manual also from the internet. Okay. I will not provide the solution manual, but you can find it out.
where's
I will not tell you. Definitely. So
okay.
you have
So
to find it out.
sometimes we need some help, right? Because there are some
Yeah.
critical problems and we need the guidelines.
Actually, I told you already that every book has solutions, and you have to just find out it or search it for that. Okay, and the teacher definitely will not give you the solution manual. So you have to find out and find your own way. But
Okay,
I'm telling you that the solution manual is available. Okay.
Okay.
Is there any other question?
So okay, now you're not. You said you'll not provide us with the solution manual.
Yes.
What if we solve a problem and then forward it to you to check whether it's correct or not?
Actually, the thing is, it is practically impossible if you do the problems and find the solutions, and it is not possible for me to check all of your I mean solutions, individual solutions. It is not possible. So I prefer that you solve it, you check it with your friends, because there will be different solutions, and you can check with your friends also whether I mean if they match with each other. I think it is fine, and I already told you that you will find the solution manual. So don't worry. The solution
Okay, sir.
manual is there on the net, and maybe you can, if you talk with your senior brothers, then also you can find it from them as well.
Okay, sir.
So this is not a new course, this is an old course, so people are having solution manual from years to years. So you can check with the solution manual as well.
Can you provide us with your email? So if anyone has a problem, we can contact you.
Yes, you can write my email as well. You can write my email as well. But actually, in the email, I mean, specific solution I can solve. But if everyone tries to give their problems, then it will be difficult, you know. Okay. Try to solve it by your friends, from your friends. Then talk with me, because I should be the last one to talk.
Okay, sir.
So if you cannot solve, then I will try to solve. Okay.
Okay. Okay, sir.
This is the at the rate. Okay.
Okay.
So is there any other questions? If you don't have the other questions, then actually I should stop the slides, and then maybe in the next week we will start with the second chapter of this book. And this was a very easy chapter, easy in a sense that you have the idea about sets, you have the idea about probability, and it is a very basic chapter to solve. We have tried to solve different kinds of problems, and I should say that there will be a class test very soon. So you try to take preparation for the first quiz or first class test. Maybe I will prepare a class test by using Google Classroom, and there will be a class test very soon. So try to prepare yourself regarding the set theory and the probability, and try to solve it. Try to understand the basic, because the basic is very important. Basic, if you don't know the basic, then you will not be able to solve the problems. So the basic idea is very important. And remember one thing, you can have different, actually in this pandemic situation, as the questions, actually you have to solve, you have to give the exam in the net. So I will try to make the questions by myself. So the questions will not come from directly from the book or directly from the net anywhere. So the questions will be unique, or the questions will be prepared by me. So directly the questions may not come from the book. So you have to understand the problem. If I give any problem to you, you have to understand what is the problem and what is the solution. You have to solve it on that particular time. If you try to find out from the net or from the book, you will not find it. So, and the time will also be short for answering the question. So I think it is better for you to prepare for yourself by understanding the basic. Okay. So if your understanding is clear, then you can solve it, no problem. Okay. So best of luck. Thank you very much.
Okay, sir. Thank
See you
you.
in the next class. See you in the next class.
Inshallah.